Welcome back to our next lecture in engineering mechanics, EGM 3512, in which today we will focus on the center of gravity and centroids. And if you never dealt with these before, that's exactly what the lecture is about. I will introduce them to you from a scientific standpoint or from an engineering mechanics standpoint. So let's take a look at our actual objectives here today. So first, I want to actually define and introduce the center of gravity for 3D objects. And no worries, we will very seldomly deal with 3D objects in this class when it comes to the center of gravity, but it's always good to start from that high level and then work our way down to 2D systems, as we will see later. However, before we go down to 2D systems, we actually want to be able to differentiate between the center of gravity, the center of mass, and the centroid. So these are often used interchangeably, but they have a specific definition. And they also have, as you will see, very much the same kind of formulas to calculate them, but they are different in a certain sense. And our goal is to actually differentiate those clearly. Once we've done that, we will actually reduce our analysis to look at only 2D systems, because you will see those most often. And as you will see in the homework that I will look at with you in just a second here, you will mostly deal with two-dimensional systems here. Then we will calculate, of course, the centroid location for a specific defined area, and we will define that through a function that looks scary first, but hopefully I will be able to decipher that for you. And then our ultimate goal is to actually determine support reactions of a simply supported plate with a random shape. And the random shape here actually then goes back to the function f of x, and that's why we first talk about that.